Let's go ahead and finish up our notes for 4.4. We're going to start off with this suspension bridge. The suspension bridge has its weight uniformly distributed along its length and has twin towers that extend 75 meters above the road surface and are 400 meters apart. The cables are parabolic in shape and are suspended from the tops of the towers. The cables touch the road surface at the center of the bridge. We are supposed to find the height of the cables at a point 100 meters from the center, assuming that the road is level. So we've got a road going along, and then we're going to have this bridge. We'll make it red like the Golden Gate Bridge. I think it's red. Anyway, my bridge is going to be red. So what I know about these towers is that they are 75 meters tall. 75 meters. And they are 400 meters apart from each other. Okay. Then they have a cable that's suspended between the two towers, and that cable touches the surface of the road at the center. So this cable suspended from both towers and touches the road surface at the center. So that makes like a parabola shape. And we're supposed to figure out the height of the cables at a point that's 100 meters from that center point. So we're going to be working from that center there. So it'd probably be a good idea if we just orient ourselves from a point of reference through this center. So if I just like go ahead and make this point here where my x and y axis meet. So I'm going to make this the x-axis, the road, and then through the center of the bridge is going to be my y-axis. So that this ordered pair here would be 0, 0 because it's the origin. And then remember that it's 400 meters from post to post. So if I'm here in the middle, then to get over to this post would be 200 meters. And then to get up to this point here would be 75. So this ordered pair will be 200 for the x-coordinate, 75 for the y-coordinate. So what my strategy is going to be is that I will make an equation that's going to represent the path of this wire. So I'm making an equation for a parabola that has a vertex at 0, 0, and a point on the parabola will be 275. So here's my strategy. Write an equation for the parabola. With a vertex at 0, 0. And a point at 275. So how are we going to do this? We're going to use that vertex form, y equals a times x minus h squared plus k. And I'm going to substitute in the things that I know. What I know is that my vertex, hk, is at 0, 0. And then I have a point that is x equals 200, y equals 75. So y equals 75, x equals 200. So then I can substitute in values for every letter except for a. So if I work through that, 75 equals a times 200 minus 0 squared plus 0. So So 75 equals A times 40,000. 1, 2, 3, 4. Yeah, 40,000. So then A would be 75 divided by 40. That's about 400,000. 400,000. No, 40,000. My bad. 40,000. Okay. That's actually going to simplify to be 3 over 1,600. Okay. So that's the value for A. So then we're going to rewrite this vertex form. So y equals A, which was 3 over 1,600, times x minus h, which was 0, squared, plus k, which was 0. So the equation for our parabola that makes the supports for that bridge is going to be y equals 3 over 1,600 x squared. So every point on here is going to follow that rule, y equals 300 over x squared. So then to answer their question, which was to find the height of the cables at a point 100 meters from the center, we'll go over here 100 meters from the center, and this is going to be 100 comma what we're looking for. So what we're going to do is we're going to sub in 100 for x. So y would equal 3 over 1,600 times 100 squared. Should have a calculator here somewhere. So we got 3 over 1,600. Oh, I could have made that my fraction button. I'll do that. That'll be fun. So 3 over 1,600 times 100 squared. So that is 75 fourths. So whatever 75 divided by 4 is, 75 divided by 4, 18.75. So that cable would be 18.75 feet, or excuse me, meters above the ground. All right. So we are going to skip this Norman window, and when I say you should thank me, I really mean that problem is extremely challenging. So we're just going to skip it for this year because, you know, time is short and COVID is real, according to scientists. I mean, it is what it is. So we're going to skip this one for this year. Moving on. Life cycle hypothesis. An individual's income varies with his or her age. The following table shows the median income I of males of different age groups within the United States for 2012. For each group, let the class midpoint represent the independent variable x, and then for the class for the class 65 years and older, we will assume that the class midpoint is 69.5. So what you'll notice is the class midpoint is going up by 10 for each class. So we are going to use the midpoint as the x-coordinate and the income as the y-coordinate. And we're going to use our graphing calculator to create a scatter plot. So remember, in order for us to get our data into the calculator, we need to be working in the stat menu. So we'll go stat, and then we want to do number 1, edit, and we'll put our data in there. I'm going to clear these lists. So I go up to the name of the list, push clear, and then down, again, up, clear, down. and then I can type in my values. Okay. Once those values are typed in there, we're going to want to look at the scatter plot. So to look at our scatter plot, we need to remember to turn on the plot. That is done in stat plot. So second stat plot, go into plot 1. I'm going to turn that to on. Scatter plot is that first one. My X list is L1, my Y list is L2. And then we do zoom number 9. So zoom number 9. And here's my data. It sure looks like it is going to be a quadratic or a parabola. There we go. So comment on the type of relation that may exist. I think that it is quadratic in nature. So as the class midpoint increases, the median income increases to a point, and then once you reach a certain age, the median income decreases. But I think it's a parabola, and that's what they're asking us to say. So let's go. Part A. We think it is a parabola or quadratic, because what we see on our screen is a dot here, 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 and a dot here. Letter B, use a graphing utility to find the quadratic function of best fit that models the relation between age and median income. So now we get to actually find the model. So remember that we're going to do in stat, arrow over to calculate. So we go stat, arrow over to calculate, and we're going to do quadratic regression. They wanted quadratic, so that is number 5. For quadratic regression. X list is L1, Y list is L2. We don't have a frequency list, and we'll go ahead and store that. Remember to store it. One way we can do that is alpha trace for Y1. The other thing you can do is vars, Y vars, function Y1. And then we need to calculate. And here is the equation. So part B, when we do that, the equation it's going to be y equals ax squared plus bx plus c. And then the rest of the screen tells us what a is, tells us what b is, tells us what c is, and then tells us r squared. So if we need to type in the model, then we would just fill in the a, b, and c with the numbers on the screen. And if we look at y equals, you can see there it's done that for us. You'd want to pay attention to what you're supposed to be rounding to. And then if we look at the graph, it's going to go ahead and put that on there for us, which we can then sketch. Looks like a pretty darn good model. So we've done that now. Part C. Use the function that you found in part B, to determine the age at which an individual can expect to earn the most income. Since every ordered pair on here has an x coordinate and a y coordinate, where the x-coordinate is age and the y-coordinate is income. It's median age and then income. Where on here would we find the highest income? Well, that's going to be here at the max, which is the vertex. So we have a couple of ways to find that. One way we could find that would be to take opposite b over 2a from our model. But we can also ask the calculator to help us find that. So part C wants us to tell the age at which an individual has the most income. So we need to find the max. And we can do that on our calculator by doing this second calc right there. So second calc. And we need to find the maximum. So number 4. And then we have to do left bound, right bound guess. So left bound, go to the left, and then go to the right for right bound, and then go to the top for guess. So this is telling me 2 pieces of information. It gives me an x value and a y value. So remember that each ordered pair, the x coordinate is the age and the y coordinate is the income. So the question they asked is, at what age would a person earn the most income? Nope, the question that's asked is, C asks what age, and D asks what is the peak income. So for C, they're wanting the age, which we remember is the x coordinate. So for part C, the age would be 47.98 years old. And then for part D, they want to know the income. So for part D, the income that would go along with that would be the y coordinate. So that is $48,007.92. Letter E. With a graphing utility, graph the quadratic function of best fit on the scatter diagram. Joke's on them. We already did that. That's where we drew our parabola on there, so part E is already done. Remember that when you finish doing one of these problems, you want to turn your plot off so that it doesn't mess up the rest of your graphing. One way to do that is to go into y equals, go up to plot, hit enter, and then arrow back down, and then that's turned off. And then you can clear out your equation you had in there and go back to a standard window by pushing zoom 6 so that it's ready for your next graphing problem.